Welcome to Saxon Math, Course 3, Lesson 110, Converting Repeating Decimals to Fractions. Now, remember, when a fraction has a bar over the digits after the decimal, that is called a repetend. And it looks like this, and it means that the numbers underneath the bar repeat in the pattern that we see there. So this decimal 0.27 repeating would be 0.272727272727 on and on forever and ever. Now, since it goes on and on forever and ever, we can't just put it over a fraction like 100 or 1,000 and say, boom, it's done. We need to have a couple more steps in order to convert this from a decimal into a fraction. So, it's a three-step process. Step 1 is that you set a variable equal to the repeating decimal. In this case, I'm choosing f because we're converting to fractions, and fraction starts with f. So I'm saying f equals 0.27 repeating. This is the same repeating decimal. Now, then, our next step is we count the number of digits, or numbers, that repeat, and then we multiply both sides of the equation by 10 raised to an exponent equal to the number of digits. So 0.27 repeating, that's 2 digits, so we're going to do 10 to the power of 2. 10 to the power of 2 is 100. So we're going to multiply the left-hand side by 100 and the right-hand side by 100. 100 times f is 100f. 100 times 0.27272727 would be 27.27 repeating. Now notice, all we've done is we've created a number which is now not repeating, that still has the repeating portion attached at the end, which is where step 3 comes in. In step 3, we're going to subtract the equation from step 1 from the equation from step 2. So we're going to do 100f equals 27.27 repeating, and we're going to subtract 1f from the left side, and we're going to subtract the 0.27 repeating from the right side, which means we'll get 99f equals 27. We'll then solve for f, which in this case we'll divide by 99, which will give you f equals 27 over 99. And then we need to look for things that we can cancel or reduce. Now, 27 over 99, both of these can be divided by 9. 27 divided by 9 is 3. 99 divided by 9 is 11. Now we have our fraction as prime numbers, 3 and 11. So that will be our answer. So 0.27 repeating is 3 over 11. These are the steps to do what we're doing. So we're going to go through 2 examples today, and then we will have the start problem video up later. So, example 1, very straightforward. Convert 0.16 repeating, where the 6 is repeating, to a fraction. Now, there's only one digit that repeats, so we're going to do 10 to the power of 1, which is 10. So we'll have 10f equals 10 times 0.16 repeating, which will give you 10f equals 1.6 repeating. You might even have 1.6 and then the 6 repeating, because we're going to need to subtract that 6 repeating down here. So if we have 10f equaling 1.66 repeating, and we subtract 1f from the left and 0.16 from the right, then we'll get 9f on the left, and 6 repeating minus 6 repeating is 0, 6 minus 1 is 5, and 1 minus 0 is 1, so we get 1.5. Then if we divide both sides by 9, we'd get f equals 1.5 over 9. Now, in order to have that be a proper fraction, we're going to need to change this decimal here in 1.5 by multiplying by 2. which will give us 3 over 18. And 3 over 18 can be reduced by dividing by 3 and by 3 to 1/6. And that's example 1. Example 2 says the theoretical probability of rolling a 12 with 2 number cubes is 0.027 repeating. About how many times would you expect to roll 12 in 180 rolls? Well, step 1, set up an equation. F equals 0.027 repeating. One digit repeats, so we're going to multiply by 10. 10 times F, 10 times 0.027 repeating. That will give us 10F equals 0.27 repeating. Now, when we subtract that, we're going to have 0.27. And since 7 repeating is 7 forever and ever and ever, we can always move that repeating down to a later 7. So 10F minus 1F is 9F. If we subtract, these will disappear, and 27 minus 2 is 0.25. We'll then divide by 9, which will give us 0.25 over 9. Now, 0.25 is a decimal, and we can't have a decimal sitting in the top of our fraction. So we're going to multiply both the top and the bottom by whatever will make this decimal 1. 0.25 can be multiplied by 4, which will give us 1 over 36. We then can find that we would need to find 1/36 of 180 to find the number of times we would expect to roll a 12. 1/36 of 180 is 180 over 36, or 5. And that was our final example. If you have any questions, make sure to leave them in the comments on the assignment for lesson 110. Stay safe, stay inside, and wash your hands.